Just so come to this, right? So in this chapter, only one thing, one example I have shown. Only this one. This chapter I will not teach much, right? If time permits, at the end I will see, because I believe that whatever you will do for this chapter, it will be, except one or two type problem. It will be, it will be very or what you call very lengthy as far as classroom exercise is concerned. So after just explaining this example, I will go. This example means it is just like a solving your what you call solving a simply circuit problem. For example, here some typographical error is there. I tell you, the three 11.2 kilovolt generators are interconnected as shown in this figure. Right, in this figure, by a tie bar. That is your this line. Tie bar means that all these things are tied by line, right? So through current limiting reactors. Current limiting reactors means this is a reactor. Reactor means inductor, right? Actually, they put a reactor such that it offers reactance. Hence, during fault, it actually try to restrict the current, fault current, limit the fault current. Those things are beyond the scope, but that is the meaning. Right. So a three-phase feeder is supplied from the bus bar of a generator A. Actually, it's a typographical error. This is generator A, this should be B, and this should be C. But all these cases, it is type as A. This is A, this is B, and this is C. Right. And your what you call impedance of the feeder. This feeder is 0.12 plus J 0.24 ohm. Right. Per phase. You have to compute the maximum MVA that can be fed into symmetrical short circuit at the far end of the feeder. I mean, you have to find out what is the maximum MVA. If you can find out the fault current, multiply by the voltage, then automatically you will get your what you call that your MVA rating, right? So this is a looking at this. Nothing fault has occurred here. Here, this is the fault point A. So fault has occurred here, right? And this CB stands for circuit breaker. So this is A, this is B, this is C, right? So that's why generator reactance is 8%, 8%, 8%. So 8%, 8%, 8%. XAG, XBG, XCG, all 8%. This is B, huh? This is C. So it is typographical error. And your MVA rating, it is 40 MVA, 50 MVA, and 30 MVA. But you have to take it to the common base, right? So what you do, voltage is set 11.2 kV, right? And you assume then base base voltage is 11.2 kV and MVA is 50. Then you find out base impedance ZV, kV square upon MVA. So this much of ohm. So feeder resistance is 0.12 plus impedance is 0.12 plus J 0.24 divide by 2.5088. So converted to per unit. Feeder is gone, right? It is over. Now base MVA is 50. So all these reactances, all this is A actually, yeah. This is A is okay, this is B, this is C. Typographical error. All these reactants you have to convert to common base of 50 MVA because voltage is 11.2 kV. Here also 11.2 kV, here also 11.2 kV. So need not bother about the voltage because same, right? But you have to convert all these things to common MVA. So 50 MVA base we have taken. So for generator B it will remain as 8%, so 0.08. But these two and these two will change, right? Therefore, XAG will be J 0.08 into 50 upon 40. So this is per unit, 0.1 unit. XBG, its rating is 50 MVA and base is also taken 50 MVA. So it will remain as it is. XCG will be 50 upon 30 into J 0.08. So this much, right? So, and your what you call, and then your all these thing, this reactor A, B, C, all are same. Therefore, XA will be 50 upon 40, right? So it is 0.125 and XB is 50 MVA base because this is 50 MVA base. For it will be remain as it is, and XC will be again your J 0.1 by into 50 upon 30. So 0.166, right? This way you convert this for all these element your parameters into per unit. After that, I told you that during fault that all the voltages is one angle 0, so it can be represented by single source, and then you take equivalent impedance, right? Then how things will happen? Look here, this is C and this is B. These two, I mean this reactants are in series. This reactants are in series in per unit. Common thing is in parallel. So that's why these two are in series. These two are in series. They are together in parallel. Now, a fault has occurred at this point, right? A fault has occurred at this point. That means if fault has occurred at this point, and this is the line, your what you call line impedance. Therefore, this one, first you make it that this is that voltage 1 angle 0, because all voltages can be represented by 1 angle 0. Initial assumption I have made, right? So that was at the beginning in the last class I told. So this voltage is 1 angle 0, and then this is the feeder, but fault has occurred here, right? Fault has occurred at this point. So there, this is the feeder impedance. So this is the feeder impedance, and this one should be taken from this, because this line is coming from here. This is for 8%, this is 10%, and fault has occurred here, right? So this one is coming from here. So that's why this one is coming from here, and this is the feeder, and this is the voltage. This is just this portion only you have to see, and then you make series parallel combination. Now you do the circuit analysis, right? So all these things, finally you find out equivalent impedance of this circuit, right? This equivalent impedance of the circuit. You see, every step is shown. First step, second step, third step, fourth step, everything is shown. But here final value is computed. This is correct. This computation I have also checked. This is no typographical error. This computation is correct, right? So this is, and your MVA rating will be voltage into fault current into MVA base, right? So ultimately fault has occurred here. So whenever you do, and this voltage is 1 angle 0 you have taken. So after it is solving like a simple your circuit analysis problem, and then this is your what you call the fault current, and this is ZF. So fault current will be V0 upon magnitude of Z. Only we want magnitude, right? So this is IF, and this is V0 again. Therefore V0 into fault current into MVA base. So this basically it is V0 square upon magnitude Z. So magnitude Z is this much. This is your 0.1727, and voltage is magnitude is 1, right? So it is basically your 1 square upon Z into 50. So roughly 289.5 MVA. Only these two examples you will see from this chapter. Other examples, everything should be skipped. You should not study this, right? You should not study this. This is not for you. You should not study this, right? Because this is not possible in the class as a classroom exercise. This is also you should skip. So for this chapter, only that much, right? So, but here we have to study from here, right? Symmetrical components. So basically what happened, that sometimes when system is unbalanced, that we can make that your what you call voltage, phase voltages or current in three different component, and these three different components says that is positive sequence component, negative sequence component, and zero sequence component, right? So whatever little bit introduction it is written, the knowledge of voltage and current in one phase is sufficient to determine the voltage and current of other two phases, because if the balance system, other two phases, the angle differs by 120 degree, right? So real and reactive powers are three times the corresponding per phase values for balanced system. But when the system is unbalanced, the voltage, current, and phase impedances are in general unequal. So unbalanced system operation can result due to unsymmetrical fault. Example, line to line fault, double line to ground fault, or single line to ground fault. I mean, it is like this. Suppose three phases are there, A, B, C. It may be line A to ground, or line B to ground, or line C to ground fault. Then line to line fault. That means phase A and phase B, there may be a fault, or phase B or phase C, or phase C or phase C, there will be a fault. Then another thing is double line to ground fault. That is very rare. Suppose A and B phases, two are short circuited, and along with that it touches the ground. So this fault is very rare, this kind of fault. But there is a strong possibility that it happen, right? And another type of fault is there. Suppose conductor opening. Suppose one conductor suddenly open, right? That is called conductor opening fault. So these kind of things are there, but that is very rare, right? Those conductors have a very high tensile strength, right? So not all of a sudden it will not cut or it will not tear, right? So double line to ground fault or single line to ground fault. So unbalanced generation may also result when the loads are unbalanced. Such an unbalanced operation can be analyzed to symmetrical components, where the unbalanced three phases, voltages, and current are transformed into three sets of balance-based voltage and current called symmetrical component, right? So now this is very interesting and very easy mathematics and electrical engineering. for false studies or unbalanced system analysis, this is very effective, right? So a set of three phasor equal in magnitude displaced from each other by 120 degree in phase and having the same phase sequence as the original unbalanced phasor. The set of balanced phasor is called positive sequence component. Similarly, a set of three phasors equal in magnitude displaced from each other by 120 degree in phase and having the phase sequence opposite to that of the original phasor. Suppose original phase is in clockwise, the negative sequence will be anti-clockwise, right? This set of balanced phasor is called negative sequence component. And another thing, a set of three phasor equal in magnitude with zero phase displacement, but I mean they all are in the same phase, right? From each other. This is called zero sequence component. This component of this set are all identical, right? I mean A, B, C, I mean all these things all along the same phase, right? So these three sets of balanced phasor are called symmetrical components of the original unbalanced phasor, right? So before coming to the next thing, just one thing I'll tell you here, that suppose you have, just I'm putting it, suppose I'm just making it like this. Suppose you, these three phases, right, three phases, suppose this is your VA, just making it, this is your VB and this is your VC, right? Now question is that this is 120 degree, this is also 120 degree and this is also 120 degree, right? So VB is, assuming that VA, VB, VC, their magnitude is same, for example, that when you write VB, it will be basically, if their magnitude is same, VA angle minus 120 degree, because it is your, what you call, it is lagging. Suppose if A is reference, if A is the, if this phase is reference, so VB is equal to VA minus angle minus 120 degree. This one also you can write VB is equal to VA angle 240 degree, right? Similarly here, if you see that VC, you can write VA angle minus 240 degree. That means VC is equal to, you can write VA angle 120 degree, right? Just to add 360 here, also added 360. Now if you define beta is equal to, say, angle 120 degree, for example, is equal to e to the power j 120 degree. That means beta square, that means beta square e to the power j 240 degree, that is angle 240 degree. Therefore this VB you can write beta square VA. Similarly VC, this is angle 120 degree, because minus 240 means angle 120 degree. So beta is equal to angle 120 degree we have taken. Therefore VC is equal to beta angle VA, right? So VB is equal to beta square, that means VA is equal to VA, because this is reference. VB is equal to beta square VA and VC is equal to beta VA, right? That means, that's why here it is written, assume that the three phases are represented ABC such that the phase sequence is ABC, says VA, VB and VC are balanced voltages characterized by equal magnitudes and interphase differences 120 degree, then the set is said to have a phase sequence ABC, positive. Suppose VB lags VA, I told you, VC lags VB, and assume VA is a reference phasor. So VA is VA, just now I told you VB is equal to beta square VA and VC is equal to beta VA, where complex phasor beta is defined as e to the power j 120 degree, right? This way, just now I explained, I explained here, right? Therefore, beta has the following properties. From your complex number, you know everything. So, I mean, during your joint entrance, you have prepared so many things, right, for mathematics. So beta square is equal to e to the power j 240 degree, it is equal to, I told you, lagging it is beta square is equal to beta conjugate, because it is beta square is equal to e to the power minus j 120 degree. So it is nothing but a beta conjugate, and beta square conjugate is equal to beta. Sometimes this property is required, right? This is also, you know, and beta cube is 1 because it is the power j 360 degree, and 1 plus beta square will be 0, right? So this has the, this you know already. So beta square is equal to beta conjugate. And if you take conjugate of this both side, so therefore beta square conjugate is beta cube 1, and 1 plus beta square is equal to 0, right? Therefore, if the phase sequence is ACB, if it is opposite, I mean if phase sequence is ACB, that means if or what you call, this is, we have taken ABC. If it is instead of VB, I mean I'm making it once again here, right? If it is ACB, Suppose this is your VA, this is your VC, this is your VB, right? So in that case, VC will be VA beta square and VB is equal to beta VA. If phase sequence is ACB. For negative sequence, it will be just opposite. That's why it's at the beginning, and VA will be as usual VA. So just opposite, because now it is instead of ABC, now it is ACB, right? Therefore, your in that case VA is VA, VB is beta VA, and VC is, in this case, the phase sequence is your ACB. It is written here that phase sequence is ACB, that is negative sequence, just opposite to the positive sequence, right? Therefore, now in what you do, that VA, VB, VC, it represent an unbalanced set of voltages. The three-phase balance acts are written as, suppose your VA1, VB1 and VC1 positive sequence set. When suffix is 1, it is positive sequence set, right? VA1, VB1, VC1. This is positive sequence set of voltage. Now when suffix is 2, that is VA2, VB2, VC2, it is negative sequence set of voltage, just opposite to the positive sequence. And VA0, VB0 and VC0 are zero sequence set, right? So they have also some properties, right? So a set of, therefore for balancing, just now whatever we have explained, VA1 will be there as it is a reference one, VB1 will be beta square VA1, and VC1 will be, it is a typographical error, it will be beta V1, right? VC1 will be beta V1, right? So I'm just making it here, it is a typographical error, that is your VC1 will be beta VA1, right? So here it is a typographical error, so VC1 should be is equal to beta VA1. Now for negative sequence, VA2 is the VA2, so therefore VB2 will be beta VA2 and VC2 will be beta square VA2. So 9.2 equation, it should be beta, VC1 is equal to beta VA1. It is a typographical error. And a set of zero sequence phasor, that is VA0, and it is actually VB0 is equal to VA0, VC0 is equal to, here it is a, it is because of printing thing, VB0 is equal to VA0. I mean here all are same. Here for zero sequence it is all are same. It is VA0, then VB0 is equal to VA0 and VC0 is equal to VA0, right? So that's why it is your VC0 is equal to VA0. So there, now when you represent this, suppose this is positive sequence, that now VA is equal to then positive sequence voltage plus its negative sequence voltage plus zero sequence voltage. Therefore VA is equal to VA1 plus VA2 plus VA0. Breaking three components, add this, you will get VA. Similarly, VB will be VB1 plus VB2 plus VB0. VC should be equal to VC1 plus VC2 plus VC0. So now positive sequence phasor diagram, suppose this is VA1, this is VB1, this is VC1, and this A is the reference, this is the reference phasor. Therefore, same as before, this is VA1, it will be beta square VA1, it will be beta VA1. Now when you make the negative sequence, right? Anyway, your VA2 is your what you call, this way also you can draw, no problem, right? VA2 is the reference phasor, right? Therefore, VC2 will be beta square VA2 and this one will be beta VA2, right? And for zero sequence, all are in the same phase, all are in the, they are in the along the same phase. So this is VA0, this is VB0, this is VC0. VB0 is equal to VA0 and VC0 is equal to VA0, right? Therefore, that breaking this for unbalanced system, this is important. So we are breaking this component into positive sequence, negative sequence, and zero sequence, right? So this way we represent. Things are very simple. I mean, very simple. Now, when you put this, so now equation 5, 6, 7 in terms of VA1, VA2, and VA0, we can write then VA1, VA is equal to VA1 plus VA2 plus VA0. Now VB is equal to that VB, your VB1, if you look at the VB1, that is beta square VA1 and VB2 beta VA1 and VB0 is equal to VA0. So what you can do is all these things VB1, VB2, VB0, VC1, VC2, VC0, you replace it by your all A component. So VA is equal to VA1 plus VA2 plus VA0. VB is equal to beta square VA1 plus beta VA2 plus VA0. VC is equal to beta VA1 plus beta square VA2 plus VA0. That means in this equation, you submit VB1 is equal to your beta square VA1, VB2 is equal to beta VA1, right? All these things you substitute your this thing in this your VB1 is equal to beta square V1, and your VB2 from here you will get it VB2 is equal to beta VA2, right? So in terms of this equation, this VB equation in terms of VA1, VA2, VA0, VC also this equation VA1, VA2, VA0, right? All these things you substitute, then you will get VB is equal to beta square V1 plus beta VA2 plus VA0. VC is equal to beta V1 plus beta square VA2 plus VA0. Now, if you put them in a matrix form, then it will be VA, VB, BC, then 1 beta square beta, 1 beta beta square, 1, 1, 1. This is VA1, VA2, VA0, right? Or you can write, this is a phase voltage. So that's why P stands for phase. It is equal to VA into, this is symmetrical component. That is A stands for symmetrical. That is A into VS. A is equal, VP is equal to then VA, VB, BC transpose. VS is equal to VA1, VA2, VA0 transpose, and this is your A matrix, right? Now that is VP is equal to ABS. Multiply both sides.
Sir,
tell me.
Sir, can you just explain how we got 9.8, 9 and 10?
9.8,
9 and 10.
9.9. Here it is VA is equal to VA1 plus this is first thing is understandable, right? Second thing is here. Second thing is your VB1 is equal to beta square VA1. You substitute here beta square VA1, right? Then your what you call here VB2. VB2 is equal to beta VA2. VB2 is equal to beta VA2, and VB0 is equal to VA0. Similarly, VC is equal to, you come here, VC1. VC1 is equal to beta V1. This is a typographical error. You correct it. This is written by the typography. It will be beta V1. So VC is equal to beta V1. Then VC2 is equal to beta square V2. If you come here, VC2 is equal to beta square V2 here, 9.3. Beta square V2. And VA0 and VC0 is equal to VA0. Zero sequence component, all are equal. Now it is okay?
Okay, so how did you get 5, 6, 7?
Where it's 5, 6, 7. This is actually for an unbalanced system VA, we are breaking into 3 components: positive sequence, negative sequence, and zero sequence. That's why VA is equal to positive sequence voltage plus negative sequence voltage plus zero sequence voltage. This is VA. We are breaking it into 3 components: positive sequence, negative sequence. This is a positive sequence diagram. This is the diagram. This is negative sequence. This is zero sequence. We are breaking 3 components: positive sequence, negative sequence, and zero sequence, such that VA is VA1 plus VA2 plus VA0. We are breaking 3 components, right? Similarly for VB also. And later you will see what is the value of VA1, VB2, VA0. That will come later, right? Similarly VB also. Basically, if it is unbalanced system, suppose this A, B, C, all 3 are unbalanced. Therefore, an unbalanced voltage can be broken into 3 components: positive sequence, here it is, positive sequence, negative sequence, and zero sequence. Such that the summation of these 3 will give you that particular phase voltage. So VA is equal to this much, VB is equal to this much, and VC is equal to this much. Unbalanced system we are breaking into 3 components. Now question can arise that, sir, how we get VA1, VA2, VA0? That will come later. That will come next. What it or not? Yeah. That is the right. This is in reality. Listen. One thing. In reality, in real power system, it will not happen. This is a mathematics. But nowadays, but when somebody is doing hardware, this component can be because different type of devices are there. Actually, it can be easily corrected. But that is laboratory that will make it. But in real life, if you ask yourself, VA1, VA0, how things will happen. In real life, how we will do it. But for mathematical computation, because the unbalanced system is not easy to solve. Because I'm just giving you this thing. Suppose a transmission line generally has to be balanced, right? All 3 phases, 220 kV transmission line, 400 kV transmission line, that is unbalanced. We are based on that go for a single line diagram and your path analysis. But if by chance it is unbalanced, for example, then mutual coupling will happen between the phases. The A, B, C, C, and then neutral is there. Mutual coupling happens. In that case, what will happen? That your mutual reaction will be there. therefore compulsory security. So solving this problem will be complicated. Another thing is that when I writing this, we are trying to find out the all the everything that I square multiply by 3, it will be total. But for unbalanced system, that I square R, you make all the things I square R multiply by 3, it will not right, because you have the inductance, right? So you have the reactance. So for that, you find out in different way, right? Beyond the scope. But later you ask me at the end of this course, a little bit I can tell how we do that, right? This thing. Generally, sometimes interviews or something. Some interviews somewhere. We are not for your case or other thing, high level. Sometimes I ask this question, right? For unbalanced system, how can you control all loss? It is just not correctly I square. Also, in your theory, you have magnetic people circuit, right? There are many things there, but I also thought I have not taught theory anyway. By giving you just before previous batch I might have taught, right? But that I have also taught. I used to tell them many things, and many students are very interested. I said ultimately everybody will go for a software job. Everybody will go for some coding, very fast coding. They want to learn many things. Still, if you are interested, I'm telling you, right. But most of the students nowadays, I mean, all not only you people, everywhere, right, everywhere. Everybody is interested about something else. Still learning artificial intelligence, all sorts of things. But at the same time, I tell another subject, although I'm not a computer science man, that is cyber security. That cyber security is a very important thing. And everybody is interested in those things. He or she will learn many things. Cyber security, artificial intelligence, learning, your application is there. But cyber security is another, in my opinion, I'm not from computer science, but in my opinion, I think in computer science, cyber security should be a major thing compared to any other thing, right? Like otherwise, how this software business is going on. So many software companies you are buying, your transaction, money transaction, you are buying so many things. Right? So many issues are there. So online things, that is cyber security for them is very important, right? You do not know so many websites. For example, so many websites are there. You do not know which website is fraud and which website is correct, right? That is also another interesting thing. If you get some 10 website or 15 website, right, you have to choose one website as a reference, right? For example, Google, right? And after that, based on that, suppose whether that particular website is fraud or it is correct, right? So those things, that is the thing of cyber security. And you have to, suppose you got something, I have to find out whether that is this website is a true website or not, right? Those are, I do not know this thing, but little bit knowledge of this general knowledge I have, right? Cyber security is really this thing, very important topic in computer science, right? Otherwise, how these online business are going on, so many people are working. Another thing they call reverse engineering. Suppose a software has come out, right, and you are using, but there, and before that they have a reverse engineering group. After making all these things, they also test, right, whether any flaw or any error is there or not. But beyond that, also there may be something that makes you do not know. Right, so many issues, so many things are there. I'm not a computer science man. Our time also, when I graduated, there was no computer science CBTech, right? Those things are later started, right? But question is that those are the things, I mean, issues. Those are the, but machine learning, artificial intelligence, everywhere it is there nowadays, right? Artificial intelligence. Anyway, cyber security. Anyway, I prefer that it is the first priority. After that, everything. Otherwise, how all this online thing is going on? They have all brilliant people are sitting there and checking everything. Whether anything is any particular the hacking and other thing, whether it is there or not, all intelligent people are sitting there, right? They are so expert on this field, right? Anyway, I do not know all these things, but this is my general knowledge, whatever I read here and there. Anyway, right? So, so VP is equal to then AVS. So A is equal to, this is the matrix A. Now multiply both sides by A inverse. So VS will be A inverse VP, right? In general, it is open book exam. You can see this thing, but But here I tell one how to this. No need to remember this, but for open book you can see it. But when they are giving offline exam, at that time one tricks is there how to remember this, right? For example, if you make it A inverse, it will be 1/3 1 beta beta square 1 beta square beta and 1 1 1. If you take the A inverse, right? Now, if you take the complex conjugate of this matrix, equation 13, if you take conjugate, then it will be 1 1 1. It will be then beta beta square 1. It will be beta square beta 1. So if you take conjugate, it is 1 1 1. It is beta beta square 1. It will be beta square beta 1, right? So if you take the conjugate, that's why at the beginning, in the beginning here the property is given beta square conjugate is beta beta cube 1 and 1 plus beta square is equal to 0, right? So this is your A conjugate. Therefore, if you take A conjugate transpose, it will be 1 beta beta square 1 beta square beta 1 1 1. Therefore, from equation 15 and 16, that A inverse is equal to 1/3 A conjugate transpose. So in offline exam, when you are writing in the exam hall, I used to tell them that if it is there, so this is the only way to remember. You need not remember this. Just you form the A matrix and take A conjugate transpose divided by 3. So A inverse is equal to 1/3 A conjugate transpose. Simple thing, but easy to remember. Right? That's why it is made it here. Therefore, from this equation, we know this this is your A inverse 1/3 of this thing, and Vs is equal to now then Va1, Va2, Va0, and this is A inverse is this one. Vp is Va, Vb, Vc. Therefore, your Va1 is 1/3, then Va beta Vb plus beta Vb plus beta square Vc. That using your this thing, your using this your A inverse, right? This A inverse. So basically this is your Vs is Va1, Va2, Va0 is equal to A inverse 1/3 that is this one into Va, Vb, Vc. If you write like this, then Va1 is 1/3 Va plus beta Vb plus beta square Vc. Va2 is equal to 1/3 Va plus beta square Vb plus beta Vc, and Va0 is 1/3 Va plus Vb plus Vc, right? So in balance system, if it is balance system, for example, then Va plus Vb plus Vc is always 0. So it will be 0 anyway. Similarly for current also, no need to derive. Same philosophy for current. So current is for Ia is equal to say Ia1 plus Ia2 plus Ia0. Ib will be beta square Ia1 plus beta Ia2 plus Ia0. And Ic will be your beta Ia1 plus beta square Ia2 plus Ia0. Same philosophy. Ia1 is 1/3 Ia plus, instead of Va, Vb, Vc, you put Ia, Ib, Ic. 1/3 Ia plus beta Ib plus beta square Ic. Ia2 will be 1/3 Ia plus beta square Ib plus beta Ic. And Ia0 is 1/3 Ia plus Ib plus Ic. If it is unbalanced system, then Ia, what you write for unbalanced system? Ia plus Ib plus Ic plus In. If neutral has to be there, is equal to 0. If neutral may not be there also, because if neutral is not there also, Ia plus Ib plus Ic will give some value if it is unbalanced system, right? If it is neutral is there, say Ia plus Ib plus Ic will be minus of In. In that case, it will be minus In by 3, right? Even in unbalanced system, Ia plus Ib plus Ic may be 0, may not be become 0 also, right? Due to your numerical values and what type of fault, etc. Right? Now power invariance. The complex power in a three-phase system is given by S is equal to Vp transpose Ip conjugate. Because initially for load flow studies I told you P minus Jq is equal to V conjugate I. Therefore P plus Jq is equal to Vi conjugate. Same philosophy is used here. Vp transpose, because all three phases are there, then Ip conjugate. So Va, Vb, Vc, and Ip means phase voltages, that Ia conjugate, Ib conjugate, Ic conjugate. Therefore S is equal to Va Ia conjugate plus Vb. This is your actually typographical error. This is VBIB, huh? This is VBIB conjugate. 27. It is VBIB, typographical error. VBIB conjugate plus VCIC conjugate. That will be S is equal to, you can write now all these things, that VP transpose your IP conjugate, right? So VP is equal to what? VP is equal to AVS transpose, and IP conjugate is AIS, your what you call conjugate. This is one. But at the same time, Vp transpose it is there. So Vp is equal to, substitute, earlier we have got A into Vs, symmetrical component, then transpose, and Ip is equal to same thing, whatever we have seen, or here it is not written, but same philosophy like your Vp. So Ip will be AIS conjugate. So it is A Vs transpose. So it will be Vs transpose A transpose. This is Vs transpose A transpose, and this A Is conjugate, that is A conjugate Is conjugate, right? So A transpose A conjugate, right? Therefore, A transpose, if you multiply A transpose into A conjugate, it will be 3. Like here, for example, your where it has this is your, you take A transpose, right? You take A transpose, and this is your A conjugate, right? So if you do so, then your what you will get, that your, this is A transpose A conjugate, you will get 3 into, it is identity matrix, right? Therefore S will be 3 into Vs transpose Is transpose, that is nothing but 3 into, that is Va1 I1 conjugate plus 3 into Va2 I2 conjugate plus 3 into Va0 I0 conjugate, right? So this is actually sum of symmetrical components power, S is equal to. So these are simple thing, but a little bit practice is required for example. How did you do for the load flow studies in the first problem? How did you do that? What about the slack bus power? Everywhere I put some load on the slack bus. What is the, how you did it? How did you do it? Anybody? One person can tell. It is not question of that right or wrong. Just I want to know. No answer from your side? Hmm. That was a dummy parameter, right? No, that during iterative process, when you are writing the equation, that slack bus thing should not become.
So that won't even come into the equations, right?
It will never come. And second thing is, slack bus is changed. You need not bother about sigma and other thing, right? I know this. That's why radial is given so that computation will be faster. What one should, what should one should write, that it is generally, in general it is your what you call YV, I is equal to YV. So capital Y say, and all small y was given, so capital Y can be immediately computed, right? No charging admittance, nothing was given. One should write all four equations, I1, I2, I3, I4, current injection, capital Y. So Y11 V1 plus Y12 V2 plus Y13 V3 plus Y14 V4. Similarly, I2 is equal to Y21 V1 plus Y22 V2. Write all four equations written. Now, that 1, 2, 3, 4, it's a radial network. So Y14 is 0, Y24 is also 0, right? So symmetrical matrix. So Y14 means Y410, Y24 means Y42 is 0, right? So and your what you call Y13 also not connected together. So Y13 and Y31 is 0. Put in this equation of I1, I2, I3, I4, right? Now those cases whose slack bus is 1, just 1 minute. Those cases whose slack, just 1 minute, just 1 minute, just 1 minute, just 1 minute. Just 1 minute. Just so what one can write, that you can write those your what you call uh, those your, you can hear me, no? You can hear me or
Yes.
not?
Yes.
So what we can write, after that you put in this equation y11, y2, all the zero element. The equation will come down as small equations, right? Then those who are case slack bus is 1, they should not consider I1. Whose case slack bus 2, that equation should not be considered. Those who are slack bus is 3, that equation should not be considered. And those whose case slack bus is 4, that equation should not be considered. Only 3 equations. And after that calculation was straightforward. This way I have made it. But first question, second question, you forget it. I have given for the same data to everyone. But this one just I wanted to test. But if I found that your equations are correct for load flow equations, all equations are correct. I mean, if slack bus is was, those who have got slack bus is 1, they might have made correct another thing. And those who have made other, all these equations are correct. At least I'll give 50% marks, 40 to 50% marks for writing this equation. So first equation, if I told the TS, tell the first question is 13 marks. Y matrix, if you compute, I'll give some marks. right? Then writing equations, I mean, if Y matrix is very simple one. So if can you write out of 13, one get 3. If your equations are correct, one will get 5. And if after that computation, I'll give 5 only, right? First, I want to see the equations. And last one is the simple one, yeah, and straightforward it is. And answers will be very close to pi model and exact model, very close to each other, right? Anyway, so this way I have given. I didn't trouble anyone. I don't want to trouble anyone, right? But when is, do you know when is the last date of your class? Is it 7th April? I have to inquire from my office, or I have to check in ERP. Any idea when is the last date of this semester of the class? I mean, not exam, class date, 7th or something, April? No idea. Anyway, I'll find out from the office or mail also. Probably 7th April. I am not sure. Anyway, so param now for the now you have what you have to do is you have to find out sequence impedance of transmission line, sequence impedance of generator, and sequence impedance of your this thing transformer. Transformer, generator, and transmission line. These are very common in power system, right? Actually, look, fast power system was actually started in, I mean, just that was nothing but a small distribution network, but that was in 1882. And today, after 140 years, today we are standing here. So a lot of development is there. And in the future also, that now renewables energies and batteries are getting a lot of importance. And all over the world, a lot of research is going on batteries, right? And because once in the future, maybe common conventional fossil fuel may not be there, like coal or oil. So at that time, we have to find out the alternative, right? So this way, your technology has developed. And in the past also, suppose 100 years, 200 years, 300 years, if you go to 1000 years back also, right? At that time, we also wonder how people used to live in those days, because there was no such modern your medical facilities. That was the first thing I always consider for humankind. The medical science is the, you know, that is your what you call that first priority, because for mankind, right? And a lot of pandemic used to come. Plague was one of the this thing in history. When I read, I found that plague was a horrible thing. Then smallpox is another horrible thing, right? Nowadays it is not there. Smallpox is not there in the world, right? And chickenpox, of course, still is there, right? But smallpox was very dangerous. And cholera was another dangerous thing, right? I mean, you will find whatever little bit I read, that people will die immediately 2 3 4 days in cholera, right? Then typhoid also, that antibiotic has come for typhoid also. It was not deadly, but it used to damage some organ of the body, typhoid, right? So nowadays technology has developed. Now this COVID virus has come. So this is also to at least 2 years, 2 years or more than 2 years, it has traveled all over the world. Hope that there is no other version should come. Let us lead normal life. Now things are getting decreased, right? So these are the certain things. But 100 years back, thing was very complicated, because First World War started in 1914. I think it was over in 1918 or so. Immediately after that, the Spanish flu came. That is Spanish flu they call. If anybody can tell why it is named Spanish flu, I'll appreciate that, right? But it was influenza, and at that time, 5 times people say, or the history, I reading something, that whatever people died during First World War, that pandemic, that 100 years back, maybe 5 times more than that, right? So that influenza, that is called Spanish. Anybody knows why its name was Spanish flu? It started, I think, in 1918, immediately after the First World War. Do you have any knowledge? But name Spanish flu, that doesn't mean that flu was in Spain. No,
It
but
was maybe bought by the Spanish sailors or something like that.
no. Actually, actually, only thing in those days, whatever newspaper was there, nobody used to publish the news. Only Spanish newspaper used to publish that. That's why name came Spanish flu. right? They used to, they never. But if you read the history, that how I was reading, but not to not to discuss here. Had it been in the regular classroom, I should have told you that is very painful. But nowadays, online teaching, everything we are making it. Remember, in those days also schools are there, universities are there, colleges also there, 100 years back, right? But at that time, look at their education at that time, right? So everything is totally totally messed up, right? So anyway, so history says that regular interval it comes, this pandemic. Maybe in future also, nobody knows. In future also, again, after maybe many years, nobody knows. Again, something may come, right? But history says that, and I was reading so many interesting thing about this. Still, from that also, some people got survived in those days. Maybe their immunity power was more, right? But still, this is very, this thing, this pandemic has troubled everyone for last 2 years. I pray all the time, pray that it should not, let us lead our normal life. At present, things are much better now. It is no other version I have not seen anywhere. Let this Omicron is the last one. Let it die down. This is the thing. Otherwise, you people are in the, most of you are in the residence, and more than half of your hostel life. That is, I always tell that this is most enjoyable life, right? My daughter also will say my college life is over without almost going to the college, right? In any way. So hope that it should not come, and it should come to normal life, and hopefully that everything should die out. I am aged man also. I had also a lot of tension, a lot of anxiety, right? Because initially when started and hearing news here and there, so my relative or my friends outside, right? So I was also worried. Anyway, now now come to this sequence impedance of transmission line, right? So today maybe 1 minute, then I'll stop. So parameters of transmission line, that is characteristic of transmission line we have studied, right? So it's a static device. So hence phase sequence has no effect on the impedance, because currents and voltage encounter the same geometry, right? So it's a static device, right? Therefore, positive and negative sequence impedance of transmission line will remain as Z1 is equal to Z2, right? This is actually for this thing. For zero sequence, I think I'll explain it to you next class, right? So zero sequence, I have to explain a little bit. Here it is there. So today it is not possible, but I'll explain it your next class, right? So today I am closing. It is in my computer watch. It is 10:53. Monday we'll meet it. Hold on. Mm, so actually, I also missed up many things, right? So today I am stopping this, and we'll meet it again on this thing on Monday. Right. So thank you very much. Thank you very much. Right.